In the field of genomics, there's this pervasive problem where things like genetic testing, ancestry inference, pretty much all genomic analyses are biased to work better for certain groups of people. In my lab, we think that genomics should work equally well for everyone, and we're working to make this happen using a new paradigm of genomics, pangenomics. So, genomics is the study of genomes, the instructions for how to build a living thing. Everyone in the world has a totally unique genome. Differences between these genomes, which we call genetic variants, encode biological differences. These can be things like your hair color, or more medically relevant things like risk factors for disease. So it can be very important for doctors to be able to identify and characterize a patient's genetic variants. This is typically done by taking the patient genome and comparing it to the reference genome. The reference is the standard copy of one person's genome that's used as the basis for pretty much all of genomics. And even though this reference is just one person's genome, it generally works pretty well for comparisons like this one, and we can usually very easily identify the variants. The reason this is so easy is that human genomes are generally very, very similar to each other. On average, we're about 99.9% identical. However, in that remaining 0.1% of the genome, the patient and the reference can look very different. And if that difference is too great, it might be difficult or even impossible for us to make a meaningful comparison and to identify these variants. This is the root cause of that bias that I mentioned earlier. Because we're reliant on a single reference genome, which is essentially just the genome of some guy they found in Buffalo, New York, if you happen to be genetically different from this one guy from Buffalo, then all of genomics just doesn't work as well for you. And, and this can have real consequences. Say this gene is the BRCA gene, and our patient has a variant putting them at a high risk for breast cancer, where the reference has a neutral variant. If we can't identify the patient's variant, we'll falsely assume that they have a low risk for cancer, and we might not recommend that they take important preventative measures. And all of this is just because the patient happens to be a little different from this one guy. So in my lab, we're trying to solve this problem by replacing this one guy's genome with a collection of genomes, or a pangenome. A pangenome will better represent genetic diversity, meaning that it's more likely for a patient to look like something in the reference, making it easier to make these comparisons and helping to reduce this bias. I'm working on the computational tools to represent these pangenomes and to perform analyses like this one. By switching to a pangenome reference, we can both better represent human genetic diversity and improve these analyses to make genomics work for everyone. Thank you.